Hello students, digital signal processing is an important subject in communication, and Z transform again is an important tool for understanding the digital signal processing, or we can say the signals, images, all the inputs we have in the communication field. Z transform is a mathematical tool, as we had Laplace transform for continuous time signals and systems. What we did using Laplace transform? Laplace transform tells those things where the Fourier transform fails. For example, Laplace transform tells about the nature of the signal, whether it is growing or decaying. The Fourier transform describes only, or it converts time domain to frequency domain, because we have a sigma factor in the Laplace transform. So, Laplace transform equation is, so it is the S domain of Laplace transform is integration of x of t or minus infinity to plus infinity x of t e raised to minus st dt, where s is sigma plus j omega. So, this is real part and omega is the angular frequency, which is imaginary part, and all these things are represented, or the system or the behavior is described on S plane. So, it is sigma minus sigma, it is j and minus j, okay, or you can say j omega. Okay. So, imaginary axis and real part of S, and it is the S plane. Laplace transform is applicable to continuous time systems and signals. We can analyze, design, change the domain of time domain to frequency domain by using Laplace transform. Similarly, for discrete time signals and systems, we have Z transform. What is the use of Z transform? Why we should study? Z transform is much useful mathematical tool for understanding the discrete time sequences and the systems. What way it is useful? So, Z transform, number one, Z transform converts a difference equation into a simple algebraic equation. As compared to difference equation, okay. Difference equation describe the discrete time systems, and we can convert these difference equations by using Z transform into simple algebraic equation. Algebraic equations are quite easier to analyze and solve as compared to difference equation. Second, Z transform converts a time domain sequence into frequency domain, into, we can say, Z domain. What it means? It is a frequency domain. Now, Z transform, third important application of Z transform is Z transform help, or it is Z transform is a tool to design digital filters. We can obtain the filter coefficient by using the Z transform. When we obtain the filter coefficients, we can predict the hardware required to implement the desired frequency response. And Z transform, we can obtain the transfer function h of z is equal to y of z divided by x of z. So, this is the h of z is a transfer function, y of z is the z transform of output and x of z is z transform of the input sequence x of n. So, this is a h of z. Now, if we replace the z by using some parameters e raised to j omega, we can obtain the frequency response by using the z transform. There are so many applications, we can find the stability of the system while designing. The system is going to be stable, unstable by using the unit circle of z transform. So, let us begin what is the z transform and later we will see some more applications of z transform. I am going to write the z transform. Before that, you should know the what is discrete time sequence. So, it is the index x of n is the amplitude of the sequence discrete and n is the discrete time. So, this is discrete time. What is the length of n here? So, it is minus infinity to plus infinity is the index in discrete time sequence is the infinite length sequence x of n and x of n is the amplitude. So, what are the values of n? So, it is plus 1, 2, 3 and so on, minus 1, minus 2 and so on. Now, for this discrete time sequence, so let us define the z transform. Z transform equation is the z transform of x of n, write in bracket x of n is equal to x of z. X is the uppercase and z is the small. X of z is the z transform of x of n, which is a complex term. We will see how it is complex. So, it is sum or minus infinity to plus infinity x of n discrete time sequence into z raised to minus n. Now, why summation is taken? Why integration is not taken here? Because integration is used for continuous time systems where we have continuous signals, okay? And here we have sequence discrete, we have to sum it. Therefore, it is a summation with a limit of minus infinity to plus infinity. Now, let us understand what is the z transform equation tells and what happens if we increase the index n. There are two sides, left side of the sequence and the right side of the sequence. We are not considering any special case here, the sequence is causal, non-causal, okay, anti-causal, what happens? We are writing the general case. So, n is equal to take any values, okay. For example, we can remove this summation sign for x of minus 3 z raised to minus of minus 3 plus x of minus 2 z raised to minus of minus 2 plus x of minus 1 z raised to minus of minus 1 plus x of 0 z raised to 0 plus x of 1 z raised to minus 1, x of 2 z raised to minus 2 and so on. And here also, so it is we have taken some minus 3 to plus 2. Okay. Now, what happens here? So, it is minus minus plus. So, x of minus 3 z raised to plus 3, x of minus 2 z raised to plus 2, x of 1 z raised to plus 1 and z raised to 0 is 1. So, this is x of 0 plus x of 1 z raised to minus 1, x of 2 z raised to minus 2 and so on. Now, note one thing. So, here z raised to plus 3, z raised to plus 2, z raised to plus 1, okay. And here z raised to minus 1, this thing, z raised to minus 2. The sequence value is multiplied by z raised to plus 3, means n is negative, index is negative. So, it goes on, it is the exponential thing and it is the product of these two things. So, it is the z transform z raised to minus n and the value of n changes and we get the product of these things by using this summation equation. Okay. So, this elaboration of the summation sign. And what is x of z basically? X of z is a complex term. X of z is a complex term. It has real and imaginary part. Real and imaginary part. We can find magnitude of z. We can find the magnitude of x of z by using some equations as we used in the Fourier transform and Laplace transform too. Now, where to represent this Z transform? Z transform has its own domain and that is called Z transform plane or Z plane. It is called the Z plane. So, it is the real part of Z and imaginary part of Z. So, it is negative imaginary part of Z and so negative real part of Z, okay, and this is the Z plane. Z transform is used along with this Z plane. Z plane helps in many cases to find the stability of the system and to predict the behavior of the input behavior of the system, what the behavior to particular input sequence. Now, we have one more thing in the Z transform which is not there in the Laplace transform. Z transform we have a circle in the centered at the origin, and how to obtain that circle. If you take Z is equal to R e raised to j omega. So, Z equal to, if it is R equal to 1, this equation okay, behaves differently. Now, R equal to 1, if you take R equal to 1, so it is 1 e raised to j omega. E raised to j omega can be written by using Euler's equation as, so it is 1, it is cos of omega minus j sin of omega. And what is omega? Omega is the angular frequency and R is the magnitude, and it is, if it is magnitude of R is 1, then what happens? We get a circle at the center. So, here when R is 1, so here the value of R is 1, R is equal to 1 and this is Z equal to e raised to j omega. Now, what happens with the circle or when e raised to j omega, okay, what is omega here? Omega is the angular frequency in radians and its value changes. If you use this equation, you can obtain the different values, we can locate the different points in the unit circle. If you take omega, okay, I am writing here, so if omega is 0, okay, R is equal to 1 we have, omega is equal to 0. So, this equation will be cos of 0 minus j sin of 0. So, it is equal to 1, cos of 0 is 1. So, it is 1. Similarly, if you change the values of this omega like this, so it is pi by 2, omega is equal to pi. So, it is omega is equal to 3 pi by 2 and omega is equal to 2 pi. So, we will get here, so it is for omega is equal to pi by 2, you will get, so it is minus j, so plus j and it is minus j and you will get minus 1 for when omega is equal to pi. So, this is the unit circle, and when frequency changes, so there is a rotation of this magnitude of j in the unit circle. There are so many uses of unit circle, we will see what is the use of unit circle in the Z transform. So, this is about the equation of Z transform and the meaning of each term present in the Z transform equation. We have studied what is unit circle. Now, what is the importance of unit circle? Okay. One more thing, is to remember is why we are getting circle. Okay. When r equal to 1, it is the 1 point only. Because of change in omega, if you rotate this value, we can obtain the unit circle. Okay. Now, what is the importance of unit circle in Z transform? When we design the digital filters and digital systems, at that time when we obtain the transfer function of the system, we get poles and zeros. By using or by locating the poles and zeros on this Z plane, we can predict the behavior of the system. First case is if poles of the system lies inside the circle, if poles lies inside circle, what it means? It means the system is stable. If all poles of the system lies inside the unit circle, system is said to be stable. Okay. Stable and decaying, stable and decaying. Okay. So, Z transform describes all the parameters of the behavior, whereas Fourier transform it is not able to describe the nature of this one. Okay. The Laplace transform, we have this sigma. The value of sigma decides the behavior is decaying, rising or sustained. Here in Z transform, we have the location of poles decides whether it is inside or outside, okay, describes whether it is decaying response or rising response or it is a sustained response. So, we have these points, system is stable and response is decaying. Second case, if poles lies outside unit circle, it means the system is unstable. System is unstable and the response of the system is rising. Exponentially it is a rising response. Now, third case, when magnitude of Z is 1. So, in this case what will be the magnitude of Z? Inside the unit circle, magnitude of Z should be less than 1. In the second case, the poles lies outside. Why the poles lies outside? Because magnitude of Z is greater than 1, that is the reason. And third case, when magnitude of Z is equal to 1, in this case poles lies on the unit circle, poles lies on the unit circle. Okay. The response of the system is sustained, the response is sustained response of the system to given input. Apart from this, this unit circle also helps in the design of FIR filters, finite impulse response filter or digital filters. Number one case, if poles are closer to, unit circle, it means the filter amplifies desired frequencies. Okay. Filters are designed to pass some frequencies or to attenuate some frequencies, to stop some frequencies. Now, by using this unit circle, when we will be having the transfer function of the digital filter, from that we can locate the poles on this Z plane on unit circle. If the pole is closer, to unit circle, it means the filter is amplifying the desired frequencies. If second case, if zeros are closer to unit circle. If zeros are closer to unit circle, it means it is attenuating frequencies. It is attenuating frequencies. You can use this as a tool. Okay. What we can sum all the discussion in one statement. Z transform is a very important mathematical tool to understand the and design, analyze the discrete time or digital systems in signal processing, and it plays an important role in the communication field to understand the speeches, sounds, music and the images.